The last procedure in making a buffer solution is by adding a large quantity of weak acid, for example, to a smaller quantity of strong base. So for sake of example, let's take ethanoic acid, a weak acid, and add it to sodium hydroxide strong base. This is neutralization. Neutralization is not function of strength, it's stoichiometry. It gives you salt, which in case is CH3COONA, sodium ethanoate, and it also produces water. So for sake of this example, I'm going to say, let's say we have 2 decimeter cube of this acid, so this is my volume of acid, and let's say we have a concentration of 0.001 mole per decimeter cube. Now for my base, I'm going to take half as much, so I take 1 decimeter cube of same concentration, 0.001 mole per decimeter cube. And I'm going to say, if you do this, then you have a buffer solution. Now let's see, why do we have that? What happens? So first thing I'm going to do is find moles of this solution, which is concentration times volume. Concentration times volume. In case of your acid, you have 2 times this, so 2 multiplied by 0.001 is simply 0.002 moles of CH3COOH. In case of sodium hydroxide, you have 1 times 0.001, which is 0.001 mole of NaOH. Now if you divide these two by their coefficient, you agree this is limiting reactant. It's going to be all consumed, so there is none of this is left. And how much of your product do you produce? You are going to produce 0.001 mole of sodium ethanoate. CH3COONA comes to life. And how much of your acid do you have left? You have used 0.001 moles of that. It's simple subtraction because it's 1 to 1. So you have 0.001 mole of CH3COOH left over. Now you have enough of weak acid and you have enough of its salt to have a buffer going. So one last way to prepare a buffer solution is to have a large quantity of weak and a small quantity of the strong. In this case, I had acid and base. It could be vice versa. Now let's look at a typical question of IB in November of, I think, 2004. This question was given. It has been repeated many times. A buffer solution can be prepared by adding which of the following, 1, 2, or 3, to 0.1 molar 50 cm cube of 0.1 molar CH3COOH. The first part is good. You have your salt being added to salt of the weak acid to this. So this is good. The second part is good because 50 times 0.1 is like 0.5, so you have 0.005 moles, and 25 times the strong base, you will have half as much. This is good. Number 3 is not good because this is exactly the same number of moles as your weak base. In this case, you're just going to use up all your acid, and you have not enough weak acid to have a buffer going. So this is not good. So it should be only 1 and 2, and in this case is B.